Okay, we're going to do, as the screen suggests, Chapter 3, Systems of Linear Equations and Inequalities. And let me go zoom in here. We are not going to cover 3.4 and 3.5. It's not part of the curriculum. We just don't cover it. All right, so I've got a problem set up here that I want to talk about. So what you do in this section is, in this chapter, is, and if you're having a little trouble with my writing, let me show it to you. I'm going to do example 6, 3.1 example 6, and here it is. And I mean, you obviously have it in your book, but it's to solve this system of equations. And this little single bracket here, or brace, is what we do when we want you to view this as essentially one problem, one equation. All right, so 3.1 example 6. Now, I could show it to you what they have here in the book, but we have an advantage when we're writing things. A lot of times we have an advantage when we're writing things in math, but I think none more so than in this type of problem. So this is just the question itself. And what the author does is actually put this tape down here to give the camera something to focus on. Okay, I think we got it. All right. What the author does is recopy and improve. Yes. All right. So here's the original problem, and the author, recopied the whole block together, the whole system, and that's kind of the standard way of doing it. But when you're doing it by hand, I like to use arrows here. So I'm going to take this equation and I'm going to do something with it. And you already know what I'm going to do. It's kind of the same thing I do to every equation ever, and that is I'm going to do the same thing to both sides in order to create a cancellation. I mean, that was in my syllabus. I always say you do the same thing to both sides in order to create a cancellation. Now, you might not see why multiplying both sides by 2, in other words, multiplying the 5, the 2, and then on this side the 5, all by 2, creates a cancellation. But look at the question underneath it. Here's the goal. I want to make it either both of the x coefficients or both of the y coefficients the same, but with a different sign. So if I can make both of these 10s, for example, or I can make both of these 4s, I'll do that. I just chose to make both of the y coefficients 4. So back to where the problem started. I knew I had to do the same thing to both sides in order to create a cancellation. So I decided the cancellation was going to be to cancel 4y with a minus 4y, and so made it happen. Here is the setup for the cancellation. All right, so that gives me 10x minus 2x, 8x equals negative 24x. And that gives me, divide both sides by 8, x equals 3. So I have a name for this. I wrote it correctly here. It's my name for it. But the name for what just happened, I call it a discovered equality. When you discover something in math, that's an important distinction. If you discover an inequality, you're supposed to do something. You have responsibility now. All right. I discovered x equals negative 3. What am I going to do with that information? Well, basically, I'm going to recopy and improve something. So it's actually called back substitution, but I'm going to take this x equals -3. And I'm going to recopy an earlier equation, recopy and improve. 5x plus 2y equals -5. Just recopy it. Well, I just recopied it there. I haven't improved it yet. The improvement is when I use my discovered fact, my discovered equality that x equals -3, it's going to become 5 times -3 plus 2y equals -5. So in other words, I recopy the 5, I recopy the plus, the 2y, I recopy all of that, but I replace x with -3. Gives me -15 plus 2y, and that just works out to y equals 5. I suppose you could call that a discovered equality as well, but I'm just going to say we now know that we know both x and y. So what's the answer? X goes before the comma, y goes after the comma. So the answer is -3 comma 5, and you need the parentheses. So the ordered pair, -3 comma 5. It's not the same thing as interval notation. This is an ordered pair where you have the x value first and then the y value. All right, so when you have a system of equations, it does go fairly quickly. Look how quickly we found the, sorry, get that all in frame. Look how quickly we found the first result. So that is, so this is called the elimination method because we eliminated the y, and it really is everyone's favorite method. Even the author kind of uses it when he has a choice. He uses that. That's the method he uses. Now, I'm doing another example here. This is 3.1 example 9, and I'll just read it to you. It's 3x plus y equals 1 minus 6x minus 2y equals -2. And I decided to do my little arrow thing again. I'm going to do the same thing to both sides in order to create a cancellation. Actually, maybe that's not what I'm doing here. I mean, that is what happened, I suppose, but really what I saw was an even number in all three positions here, so I know I could divide them all by 2 or multiply by 1/2 is what that says. So I can multiply by 1/2, just cut everything in half. In other words, there's another reason why we divide. We usually multiply if we're trying to create a cancellation, but we divide if we're just trying to simplify. But notice I get a cancellation. I guess we could look here. I have a positive 3x and a negative 3x, so that's a cancellation. But in a situation like this, I want you to think this way. You only get one cancellation per step. All right. So when I say one cancellation, I'm going to cancel this, but if I just cancel everything, well, I don't write anything down. So I don't want to just cancel everything. One cancellation, and the other one, you just actually have to literally answer what's going on here. So what do we see? We see plus y minus y, well, that's 0. And we see plus 1 and a minus 1, that's also 0. So we get 0 equals 0, which is an important idea on a problem like this. I mean, last time we got x equals whatever is -3. We got a 0 equals 0. So we get this situation. No variables, and it's true. 0 does equal 0. No variables and true, and that is something we can interpret. What that means is, well, the word is a dependent system, but it really means is we have an overlapping line. These lines are the same. There's no difference between them. In fact, I could just make one look like the other one by, well, at any point in the problem, but even at the beginning, if I had chosen to multiply the top one by -2, I would have had an exact duplicate of the bottom one. So they're really the same line in the same way that, I don't know, like -6 over -2 is the same fraction as 3 over 1. You know, there's more than one way to write something, and if you simplify it in the fully, they'll look a little more similar, which is what happened here. But really, they could be identical. I mean, they really are identically the same line. So that's going to be important in a moment. The solution is the set of everything on the line. There's only one line. Usually when you're given a system, you're given 2 lines. You think of it as 2 lines, but it's 1 line given twice. So the answer is everything on the line. The answer is an infinite number of solutions. The answer is the line itself. The line is the answer. The author kind of stops right here. I'll show you how we're going to wrap up this answer here. But for purposes it'll be important later. I like to think of rewriting this as y side equals x side. You know, y equals -3x plus 1. Y side equals x side. Now, the author won't write it literally this way, y equals 3x plus 1. They seem to like to wrap it in these, in this right here. The set, parentheses, x comma y. I'm off the camera, off the screen. All right, let me adjust the mic here. Okay. Sorry. Do that again. This is what you and I, this whole thing is what you and I would think is the answer from the y equals, all right. Actually, even right here could be the answer. But like I said, it's nice to get x side, y side. All right. But we either take this, or even we could take the original equation with a 6 in it and just write it between all of these characters, between the parenthesis, the x, or the brace, the x, the y, the other brace, and just kind of fit it in there. That is the answer. Now, you don't really have to worry about the formality of this parenthesis and everything, because none of the problems on the website actually have you write all that. They just have you write something like, you know, y side, x side, or even the equation of a line. All right. So the reason why we couldn't just put a number there like we did last time is the answer is not just a number. It is an entire line. There's an infinite number of solutions. That's what we have when we do a dependent system. All right. This series of videos is going to get awfully long if I do it in one cut. So I'm going to stop that part. That is my 3.1 video. And I'll see you in the next one.